All right, so chapter 9-6, we're going to start dealing with raising monomials to a power, which it's called powers of monomials. And at home, you'll need to take notes on just notebook paper. So write down each example as we get to it. And of course, at home, if you need to pause the video and give yourself a chance to get each problem written down, that's kind of the benefit of watching the video back. All right, so what I want you to write about powers of monomials is that we're taking a power to a power. And the reason I word it like this is because I will say this a bazillion times over the next however long we're in this section. So I always say power to a power equals a superpower. And the reason that I say this is to differentiate it from when we were just multiplying like bases. So you don't have to write this down. This is a review. This is just kind of what we've already covered so far about monomials. So when we were doing or dealing with multiplying monomials, we would have something like 2 to the third power times 2 to the fourth power, right? And when you multiply monomials, your base stays your base. And then we just added 3 plus 4, and we got 7, okay? So base stays your base, which that's still going to be the case. Oh, I just made a rhyme. Base stays your base here, but because you're multiplying this, what this really means, and I told you never have to write this long thought process out, it's just why it works, is because this is 2 times 2 times 2, that's 3 of them, and then times 2 times 2 times 2 times 2, and that adds up to 1, 2, 3, 4, 5, 6, 7, and that's where we get our new exponent. Okay, well, today we're going to be actually taking a power and then raising it to a power, and that's why I say it becomes a superpower. So what does it mean? So I'm going to take this first one, and I'm going to do here like I did when we first learned multiplication. I'm going to break it out into that long process that I said you don't ever have to really do, like I just did right now to all those 2's. I'm going to write it out once, show you why the shortcut works, and then show you the shortcut. And then we'll do the shortcut from here on out. Okay. So first thing I want to pull your mind toward is the directions. It simply says simplify. It doesn't say evaluate. Okay. So for the first few, when it's just a basic problem like this, we're going to leave it with our big exponent. And I'll show you what I mean. Here in a minute, when we get down to a little bit more complex ones, there's an extra step in there, but I'll tell you when we get there. Okay. All right. So what does 19 cubed to the 6th power mean? And this is the part where you're never going to write all this out. I'm just showing you the why behind the shortcut. So what this really means is 19 to the 3rd power times 19 to the 3rd power. And I'm going to do this 6 times because it says that it is taking 19 to the 3rd power times itself 6 times. Okay, now it looks like just a multiplication problem like we did last week. Base is 19, so base, keep your base. And then because it's all multiplication, we would add 3 plus 3 plus 3 plus 3 plus 3 plus 3, add that up 6 times, and we get what? What's 3 plus 3 plus 3 plus 3 plus 3 plus 3? 18. Okay. Now, the much easier way to do it is think a power to a power becomes a superpower. Okay. Thinking about addition, subtraction, multiplication, or division, what operation do you think would create a superpower? Yeah, multiplication. So if I just take 3 times 6, what do I get? 18. So my base stays my base. And my new exponent is the superpower that's created by taking 3 times 6, which is 18. Notice I get the exact same answer, whether I bust it out in this long thought process way, or if I use the shortcut of just multiplying the exponent to the exponent. Huh? It is, except for you're not adding, you're multiplying. And the reason I always say power to a power equals a superpower is it just helps you when you're doing a chapter test, and some of them are multiplication and some of them are a power to a power. It helps you remember that when you are simply, where was it? Here, when you're simply multiplying 2 like bases, you add. It's helping you keep it straight. When do you add the exponents and when do you multiply them? And the kind of what usually will hopefully stick in your brain is that power to a power, that superpower. Okay, so that kind of helps you keep straight. When do you add the exponents here? Or when do you multiply the exponents like this problem? And if you're ever not sure, write out what the problem means. Expand it into that big long string of what you're multiplying, and then it'll make a little bit more sense. But so we're not going to do the expanded way anymore. So for the rest of the worksheet here, the notes, we are going to just do the shortcut. Okay, so 8 to the 4th power, I'm sorry, -8 to the 4th power raised to the 9th power. So that is a power to a power. We keep our base, and because our base is negative, I'm going to put it in parentheses. And 4 times 9 is 36. And that's what you're going to circle as your answer. Not bad? Am I good to move on? All right, so let's move over to number 3. So I've got my base is 28. It's going to stay 28. And then my power to a power is a superpower. So I'm multiplying here. 2 times -5 is what? -10. All right, now this goes back to 9-4. Can I leave it like this and circle my answer? Blake, what do you think? To the what? +10. And that's what you're going to circle as your final answer. So we're kind of putting together a little bit of what we know from several parts of chapter 9 to do 9-6. Okay, so let's jump down to number 7 here. And I just wanted to show you this row because I wanted to show you that you still do it the same, whether your base is a number or your base is a variable, you still do it the same way. Your base is a b, it's going to stay a b. Your exponent, a power to a power, is 9 times -3, which is -27. Am I leaving it like this? Autumn, what do you think? I'm going to go around the room and pick on all of you. Beautiful. And that's what you're going to circle as your answer. Okay. So if you would work number 8 on your notes, I'm going to work it on here, and then we're going to compare answers and see if you got it. We're going to do that a couple of times today. So you go ahead and work number 8 on your notes, and then we'll compare answers. All right, let's kind of glance up, see if we're in the same spot. So we took 5 times -2. That gave me -10. So m to the -10, because it's a negative exponent, I deal with it by dropping it in the opposite part of the fraction. Move this or change the sign, change the location. All right, do the same thing with number 9. Work through it. I'm going to work through it, and then we're going to compare answers. All right, can I circle this, or do I need to do something different? Do I need to take it one more step? What do you guys think? How come? Does this negative not bother us? How come? That's right. The base can be negative. That's fine. It's just the exponent that you care about. So yes, we can stop there. Negative bases are fine. Negative exponents are not. All right, so now I want to have you add a little note to yourself out next to number 16 there in your notes. And this is just a little step I add in here to help you not make an error. So 5 years through teaching this, and the biggest error I find is that people forget about that poor 12. And I'll show you what I mean once everybody gets that little note written down. Add exponents of 1 where needed. So the biggest mistake that I have seen is that everybody's good with this. They're good with that power to a power. Don't write this down, okay? This part's not right, so just pay attention and don't write. A lot of people will do this, okay? And then if they even want to clean it up more, they'll put 12 on the top and they'll put R in the bottom because that's good, right? We want to keep the 12 up top and the R to the 10 on bottom. But the problem is that distribution says that everybody inside those parentheses gets that power of the 2. And what we forget that's there but not there is, what is the exponent of that 12? Somebody tell me. A 1. Every number and every variable has an exponent. We just don't ever write it if it's a 1, but it's there. So that 2 to the power also has to go to the 1. So what that's going to look like is 12, because your base stays your base, right? 12, and then you multiply your exponents. 1 times 2 is 2. Then your R is -5 times 2, which is -10. Now, this is where I was saying, because you have a variable and a number and a variable, okay, we're going to go ahead and clean this up a little bit more. Okay, and I'm going to give myself a fraction here. Why am I automatically, before I'm even thinking through this much, why am I giving myself a fraction line? What do I already see in my problem that I'm going to have to deal with? The negative exponent. So I know that because I have a negative exponent, my answer is going to be some form of a fraction. So what would go, or what would stay on top? Anything? Yeah, and which is what? 144. On the bottom is R to the 10th. And that is the simplified version. Okay. Now it seems like splitting hairs, and I kind of looked at the key and I wondered why, when it's just like this one, we didn't evaluate it. We just left it -8 to the 36, or we just left it 1/28 to the 10. And the best I could come up with is that when it's just a number to an exponent, I mean, every single problem in the key left it as 28 to the 10th power. But when you started involving variables, the key immediately went to going ahead and simplifying the number if you could, which you always can, and then just leaving the variable with the exponent. So I probably wouldn't count much off if you left it 12 squared over R to the 10. You know, maybe if it was a 7-point question, you might just lose 1 point. Because technically we left the top ones with an exponent, right? And then it says to start doing these middle ones, not leaving the exponent on the number. So I can see why that can be a little confusing. So, all right. But as long as you remember, if you've got a variable, go ahead and evaluate the number, leave the variable as an exponent. Okay. So let's just really quickly here. Again, the first thing I'm going to do is I'm going to stick that 1 there, and that is just a memory help. Okay. It's if you get it right, but you don't stick that number in there, I'm not going to count off anything. It's just you run the risk of forgetting to distribute the 4 to the 1 and to the 8. So it's going to look like 3 to the, well, 1 times 4 is 4, times S to the 8 times 4 is 32. And now let's simplify this just a little bit more. What is 3 to the 4th power? No, it's not 3 times 4. It's 3 times 3 times 3 times 3, 81. 81 S to the 32. No negatives to mess with, so that's what I'm going to circle as my answer. Everybody good on the ones we've done so far? All right, go ahead and work through 18. I'll work through it, and then we'll compare answers here in a second. All right, so we've got -5 raised to the 1 times 4, which is 4. And then we've got y raised to the 7 times 4, which is 28. And then because we want to go ahead and simplify that number to a power, we've got -5 times -5, that goes positive. We've got another -5 times -5, that goes positive. And those two positives go together to give you a positive answer of 625, y to the 28th. Remember, when your base is negative, if your exponent is even, your answer is going to be positive, okay? All right. So now we're going to jump into a little bit, it's not a harder problem, it's just going to take an extra minute, okay? So I want you to write down these steps. And the first one is the same as that one above. We're going to add one exponent if needed. Everybody done writing that? So the step one is we're going to add that one exponent. That's just to kind of help with us not forgetting. Then we're going to distribute the power to everything inside, no matter how many there are, one term or right, 10 things. You just give it to everybody. And then we're going to simplify. We've already done this. If it's a number to an exponent, let's go ahead and simplify that. And then we're going to move any negatives to the bottom. So it's nothing we haven't already done above. It's just all kind of in one problem. And the reason I'll show you why combining step 3 and 4 is really easy. Okay, so the first thing I'm going to do, step 1, very simple. I'm going to add a 1. Step 1's done. Step 2 is I'm going to distribute that power of 3 to everything inside, which means to the 1, to the 5, and to the -5. Okay, so that looks like 9, 1 times 3 is 3. F, 5 times 3 is 15, and G, -5 times 3 is -15. Now, here's what I like to do, and I think this is why combining steps 3 and 4 is super easy. I can glance at this and see right away, I'm going to have a fraction as an answer because I have a negative exponent, right? So I'm going to give myself a fraction line, and then I'm just going to simplify and put stuff where it goes in the same step. So 9 to the 3rd power is, and I've already kind of written it, I just use 9 to the 3rd power as an example. Whatever the number is, you're going to simplify it out. But we've already figured out that 9 to the 3rd power is 729. And now I'm just going to go one variable at a time and put them where they go. Where does F to the 15 go? Top or bottom? Top. Where does G to the 15 go? Bottom. And since I moved the location, I can drop the negative. And that's what you circle as your final answer. And that's why I said it's really easy to do that in one step. Yes, sir.
So what if what if the negative, so say everything's still the same besides the F, what if the 5 is negative in that?
What if the what was negative?
The F, like the F5, if that was negative with the G -5, would you have to put that?
Both would have dropped to the bottom. Yeah, anything with a negative exponent is going to drop to the bottom. And I don't think you have any of these on your homework. So I didn't pick an example like this, but if your exponent was negative and it turns everything inside negative, everything would drop to the bottom. So just once you distribute and watch your signs, once you distribute, you just kind of relocate everything that needs relocated and leave alone what doesn't need relocated. All right, last one or last two. So we're going to do this. I'm going to have you work through that one on your own, and then I'm going to work it, and then we're going to compare answers. Okay. And I think this one answers your question, Blake. Because this is an example of one like that. Are we good? All right, if you're done and you want to, Joe, go ahead and jump to 24. We're gonna do the same thing. You're gonna work it, I'm gonna work it, and we're gonna compare. Awesome. All right, so we add the 1. We distribute the 5, so we get -3 to the 5th power. B to the 5 times 5 is 25, and C to the -7 times 5 is -35. Then I gave myself a fraction line. And before I even figured out what 3 to the 5th power was, how did I know if it was going to be positive or negative? Sophia? Perfect. My exponent was odd, which meant I was going to have 2 and 2, which went positive, 2 and 2, which went positive. That gives me 4. But then that 5th one, that's the odd man out. That's going to make my answer negative. 3 to the 5th power is 243. And then B to the 25th stays up top. C to the 35th gets moved to the bottom to deal with the negative. And again, that 243, it's okay to stay up top as a negative base. It just doesn't have a negative exponent. So we're good. Are we good? Any questions? All right. So what I want to do is, for those of you at home, it's odds only, and email me if you have any questions.